Okay, so we're going to go over 1.6, number 3, and number 4. So this one says, identify whether the relation, if it's a function or a relation, okay? And then I want you to determine if the function is linear, exponential, quadratic, or neither. Then I want you to describe the type of growth and then express the relation in the indicated form. So it sounds like a lot, but don't worry. So the first part says, is it a function, right? So driver's ed course starts, wait, hold on. If you remember what a function is, let's go over that really quick. So a function is, remember we talked about this, every input has only one output, and we talked about like this idea of like the birthday function. If not, I'll link the video in your spreadsheet of videos. Okay, so all it's talking about is every input has only one output. And so one of the things that you can use was that vertical line test. Okay, so that's what you're thinking about this word function. Is it a function? So the driver's ed course started with 81 students. Students complete the course by passing the driving exam. After the first month, there were 27 students in the course. After the next month, there were not, after the next month, 9, and then 3, and then so on. So wait, what do you want me to do? So if you know Miss Johnson, what will she first do? What is the first thing that she wants to do here? How is she going to organize this information? Yeah, I want to organize it with the table. So I'm going to draw a table, right? Exactly. Thank you. Thank you. A couple of you put it down now. Yes, exactly. So this is going to be the month, and this is the number of students. Okay. So it says they started, so the driver's ed course started with 81 students. So you can think about that as the first. After the first month, oh, maybe we should think about this as 0 then. After the first month, there's 27 students, right? After the next month, there were 9 students, and you can kind of see the pattern, right? Do you guys all see this pattern? So it's definitely not being subtracted. It's definitely being divided by. I see divided by 3. I see divided by 3, right? That's what I see, just because of the patterns that are going on in my head. So is this a function? And to me, the answer is yes, because for month 0, there was only one number of students. It was 81. In month, after the first month, it's 27 students. So there weren't 27 and 35 students. It's just 27. See, this person only has one birthday. It's on the 27th. Person number 2 only has one birthday on the 9th. So the answer to the first question is yeah, it's a function. Is the function linear, exponential, quadratic, or neither? So looking at the clues that I left you here, what do you think? Yeah, it is exponential. Very good. So if you don't know, linear would have a constant. It would be like +2, +2, +2, or -2, doesn't matter. Exponential, it's times 2, times 2, times 2, or in this case, it's divide by 3. Quadratic, you remember that table that we just did where the first row of differences was different and the second row was the same? So this to me is second row of constant differences are the same. Okay. The next thing they want to know is the type of growth. Okay, well, how does it change? Well, it's exponential, so it's exponential. And then it says to make a graph or, and then label your axes, right? Okay, so I already pulled this in, so I can copy my thing here, right? So like, I'm just trying to get this other thing here. Okay, good. So, so my graph, sorry. So my graph for this one is gonna look, it says label your axes. So here, this is months, and this is students, right? Okay, so here, this is going to be 0, this is going to be 1. So after 1, I'm going to make these tens, 10, 20, 30, 40, 50, 60, 70, 80. So this is 80. So we had 81 students to start, 10, 27 for the next, and then we had 9, and then we had 3. So do you see this, like, whoosh? There you go. So how does it change? You can say it's exponential. You could also say it's being divided by 3 every single stage. Just so that you can write out that thing there. This is almost like they're asking you kind of for like the recursive rule. Okay, so does that make sense? Ms. Johnson, would you connect the dots? Nope. This one, I would not connect the dots. Remember, we talked about discrete versus continuous. This is definitely one of those contexts that it's discrete. It's discrete because we're talking about students, right? I don't have, I don't know, let's see, 2.5 students, right? Well, no, that's 20. I don't have 29.5 students. So I can't connect these dots. This is discrete on purpose, okay? This is discrete on purpose, okay? Number 4, someone said, okay, so first we have to do all those things. Is this a function? So can you guys look at this and get, is this a function? Yes or no? Does this represent a function? Yes, very good. It is a function. Exactly. Ms. Johnson, how do you know if this is a function? Well, I go up to every person and I say, how many birthdays do you have? And this person says, I have 1 birthday. It's on the 81st. I know that doesn't make sense. Just go with it. Person 1, when is your birthday? Oh, on the 80 and 2/3 day. I don't know. I'm just making stuff up. Person 2, how many birthdays? How many birthdays? How many birthdays? Now, if my table looked something like this, something like 2, 4, 3, 7, 2, 9, 4, 6. So this does not represent a function because look, 2 has a birthday on the 4th and on the 9th. What? No, this does not represent a function. So not a function because 2 has 2 different outputs. Does that make sense? Okay, next part. Is this linear, exponential, quadratic? Who knows? It's going really slowly. Oh, it's going down by thirds. Do you guys all see this? So if you don't know how it's growing, you just take out your calculator. So I'll take out my calculator. And then I subtract bottom from top. So I go 80. I'm just going to go 0.66666 because that's what 2/3 is, minus 81. Oh, and that's 0.334. And I'll do the same thing. So 80.3333 minus 80.666. Oh, look, it's the same number. But Ms. Johnson, it's off by 1. Yeah, I know. It's going to be off a little bit because it rounds it. So it's still minus 1/3. So this is me minusing 1/3. So here, minus 1/3, minus 1/3. Which again, that should tell you something. Because all these guys are the same, this is telling you what? Because these guys are all the same. What is that telling you? I'm linear. Very good. I'm linear. right? And if you didn't know that, not a big deal. You would just graph it. And when you graph these points, when you graphed these points, it would show up as a line, right? Okay, so it is linear. How does it change? It's being subtract 1/3. Oh, and then they now want you to write an explicit equation. Okay, so that means because I'm linear, it equals to y equals to mx plus b, right? So that's going to be my explicit equation. You should know who M is. He's screaming at you. He's like, look at me. I'm the star. I show up everywhere, right? Ooh, nice. Good job. That's the perfect equation. So someone asked this in the chat. I like to put stuff from the chat onto our notebook because it's almost like it's being recorded. And I don't put your name because I don't know if you want your name out there. So I don't put your name. So here, right? Someone said, hey, Ms. Johnson, is this the equation? That's exactly the equation. I'm just going to stick this right here. So how did this person know that it was negative 1/3? Like, where does that negative 1/3 show up? Yeah, this negative 1/3 shows up here and here. It's exactly, it's the slope. It's the constant difference. He likes to be the star of the show. Oops. I highlighted the X and I didn't mean to. Let me undo that. There, that's a little bit more careful, right? And then where does this 81 show up? Where did that 81 come from? Where did that 81 come from? Yes. Someone said, hey, Ms. Johnson, could you put Y here instead? Absolutely. Yeah, from the table. Very good. Okay. So, but where in the table? Specifically, tell me where to look for it. Where should I get this 81 from? Yeah, it's our y-intercept. It's where x equals to 0. Very good. So let me just draw a quick little arrow here so you guys all know where to go. Ooh. Right? That's where we go. All right. X is equal to 0. Very y is 1. Very good. Very strong work there. Okay. So if these two made sense to you, there's a couple questions on your test that look very similar to this. Like, hey, what type of growth is this? Hey, can you write me an equation for this? Hey, what does this mean? So there's a couple more questions that I want you to try. And then if you have questions, we can go over those too. Let me stop recording.